Hello everyone, welcome to the channel. So in this video, I'm gonna show you analyzing a decadal land surface temperature trend analysis using MODIS data in Google Earth Engine. So now let's get started. So to analyze the decadal land surface temperature in Earth Engine, first we have to import our study area shapefile, and we're gonna filter the shapefile and import the study area boundary of our choice. So in our previous video, we have shown you the land surface temperature video have shown you how to import the study area shapefile and calculate the land surface temperature. And the link will be given in the description to how to import a study area boundary shapefile. So now here, once you have uploaded your study area boundary shapefile, we're going to navigate to your cloud asset here in the asset section. And in that, we're going to navigate to our cloud assets. And you can able to see here, I have uploaded a shapefile called India States. So once you click this option called import into script, you can able to visualize the data here, the variable table, project, terraspatial asset, India states. So let me show you this. This is the detail of this particular data. So here you can able to visualize the details about this particular data set here. You can able to see that the details about this particular data, we have a feature index starting from 0, 1, 2, 3 and 4, and S name represents the state name. And here you can able to visualize the different state for this particular data file, has a different shape file containing different states. So in that we're gonna particularly we're gonna import our Tamil Nadu state into our Earth Engine, and we're gonna calculate the decadal land surface trend temperature analysis for the study area called Tamil Nadu. So now we defined a variable called state boundary equals to, we are referring the table variable. So this is a variable table. So we are accessing our shapefile from our asset section here. So for that we define table.filter ee.filter.eq s name. I've shown you that s name represents the state name for this data set. So to access the particular study boundary, we are defining the S name and the boundary, the state called Tamil Nadu. And next we define that map.addLayer state boundary. So we're going to add the state boundary. You can able to visualize from the below here. This is the state boundary. And we define map.addLayer state boundary. And to center this particular layer, we define map.centerObject state boundary with a zoom level of 6. So state boundary refers to this particular variable. And next, to calculate our land surface temperature using the MODIS data, we have to import our MODIS data. For that, we defined a variable called collection equals to ee.image collection MODIS 061 mode 11a2 dot select LST day 1 kilometer. So we are selecting from the MODIS data this particular band called LST day 1 kilometer. And we're going to filter with a specific filter timeline, that is from 2013 January 1 and 2023 December 31st. So for that we define filter date 2013 January 1 to 2023 December 31st. And we're going to filter with a specific study boundary, that is dot filter bounds state boundary. So the state boundary here represents this particular boundary called Tamil Nadu. You can able to see that. Next, we're going to import a visualization parameter for our MODIS land surface temperature data. So to import a visualization parameter, we defined a variable called land surface temperature visualization parameter. We set a minimum value of around to be 14,000 and to a maximum value of 16,000. So the color palettes, these are the color palettes for the MODIS land surface temperature. So the lowest here represents the lowest level of temperature, and the highest level of temperature are represented in this set of color. Next, for the visualization purpose for creating a land surface temperature spatial map, so for that we defined a variable called composite equals to collection.mean. So the collection.mean function, the collection refers to our MODIS dataset. You can able to see here the collection refers to our MODIS dataset. .mean function will give us a mean image of mean land surface temperature from 2013 to 2023. So for that we define .mean function. The next, to center this particular layer, we define map.centerObject state boundary with a zoom level of 6. And to add this layer in our Earth Engine, we define map.addLayer composite.clip state boundary. State boundary refers to this particular boundary, study area boundary. And output we defined our visualization parameter, land surface temperature visualization, you can able to see this variable here referring to this particular variable land surface temperature visualization, and output the layer name as land surface temperature. So to perform some pre-processing on LST and convert from Kelvin to Celsius, we define this particular variable called LST day equals to collection.map function img, and return img dot multiplying 0.02 dot subtract 273.15 dot copy properties image. We're going to set start time and system end time. So this particular code will perform that converts the Kelvin to Celsius. So next, to displaying our LST variation. So to visualize the LST variation, decadal LST variation, we define this particular variable called chart equals to ui.chart image dot doi series by year LST, and LST day 1 kilometer refers to our modus band here, LST day 1 kilometer. State boundary refers to our study area boundary. Reducer.mean function, and we set the resolution of this particular data is 1000 meters. And to visualize this, to view this particular result, we define print chart. So to view the decadal LST variation for each of the year, we defined to visualize it, we define print chart. So now to run this code, we're going to click this option, navigate to this option here, run script, and we're going to click run script. So in the console section, you can able to visualize the result here. You can able to see that it's generating the chart of the LST decadal change trend analysis. And similarly here, you can able to visualize the image here. And let me convert to a satellite mode here. Now you can able to visualize our land surface temperature data as a spatial map here. So now here you can able to visualize our result, the land surface temperature map here. So here the red areas indicating the higher temperature, and the yellow region representing the moderate level of LST. And you can able to visualize in the green section of this particular area here. The green areas here indicates the mountain areas or the hilly areas. The hilly area shows a low temperature compared to the other part of the study area here. Let me zoom into this particular study region here, and you can able to visualize. Let me turn off the layer 1 here. That is our study area boundary layer. So you can able to view this mountain ranges here. So the LST of the land surface temperature for this around this mountainous areas are indicated has a lower level of temperature compared to the other part of the region has a very high level of temperature. And similarly, you can also visualize here it is the areas of Eastern Ghats mountain range here. You can able to see here the green portions are indicating the Eastern Ghats mountain range of which indicating that a lower temperature around this mountain range compared to the low elevated areas has a very high temperature. And similarly, when we move towards the western part of the study area, you can able to see that these are the Western Ghats mountain ranges here. And here you can similarly the mountainous areas has a very low level of temperature compared to the low elevated areas has a very high level of temperature of LST here. And you can able to see here. Similarly here you can able to visualize there is a river that is you can able to see here. It is a river called and here you can able to visualize there is a river path here, which is a Kaveri river, which is running towards the Tanjavur district here in Tamil Nadu here. So which has a moderate level of temperature compared to the other part of the study area. And in the eastern and western Ghats mountain ranges has a you can able to see from this LST has a very low level of temperature compared to the low elevated areas of the study area. So now let us visualize our trend analysis in our console section. So in the console section, you can able to visualize our graph here. So LST day 1 kilometer mean. So this represents the temperature in degrees Celsius, and this side of this axis here represents the day of the year. So now let us visualize this graph in details. So this is LST day 1 kilometer mean by day of the year in different years. So each of the years are indicated in different colors starting from 2013 to 2023. So each of the years, the LST temperature is indicated in different colors. We can able to view from this graph here. So this particular axis represents the day of the particular year, and this axis represents the temperature in degrees Celsius. And here you can able to visualize the purple color here represents the 2023 here. So in day 125th has a recorded a lowest level of temperature, and you can also visualize this red portion here. So red portion here indicates that is 2019. So it has a temperature of around 41 degrees Celsius in the day 100, and you can also see that towards the 275 to 350 day of the year has recorded a lowest level of temperature compared between the 75th to and 175th day of the year has indicated a very high level of temperature. So you can able to see the decadal LST variation for this study area. So now let me get back to my Earth Engine here. So in this video, I have shown you analyzing the decadal land surface temperature trend analysis using Google Earth Engine and MODIS data. And thanks for watching, and please subscribe to our channel and give us a like.